Thank you so much for the introduction, and thanks everyone for joining today. So let me bring the presentation up in the foreground here. So today we're going to talk about MySQL and high availability with DRBD. I guess it is a mouthful. But anyway, we're going to take you on a step-by-step installation of all these technologies using a VirtualBox technology or a virtualization technology from Sun called VirtualBox. And that will allow us to create a couple of virtual machines on your laptop. And from there you can test out all the technologies without actually having to mess with any hardware. So it's a great way to get your feet wet, and it's an excellent way to demonstrate detail. So let's dive right in. So DRBD is an acronym that stands for Distributed Replicated Block Device. And basically what it provides is a mirrored volume for two Linux servers or two Unix servers. So basically the mirroring is done below the file system layer, but above the hardware. What that means is normally on a Unix server you would mount a volume, a hardware device, and with DRBD layer in between, all file system write activity that happens will also be mirrored to the remote machine. So how does that affect MySQL? Or how does that play into MySQL? Well, before we talk about DRBD and MySQL, I want to talk about a little bit the standard replication package that comes with MySQL and how that provides high availability, and then how DRBD solves the problem differently. So MySQL's standard replication is pretty straightforward to set up, but one of the big problems with it is that it's a statement-based solution. So what happens is the statements are sent downstream to the slave side and re-executed. And so sometimes they execute differently than they do on the primary. In particular, there are what are called non-deterministic functions, which can be in your applications, things like user function or time-based function, sysdate, and so on. And these might execute differently on the slave side. So what happens is that even though MySQL's replication is pretty trivial to set up, in the long run, it requires a lot of engineering, and errors tend to show up in the error log. But even if you're not seeing errors in the error log, you can still have differences between your primary and your slave side, and unfortunately, those can even go. Those can even occur without you knowing. And typically, the best way to have sort of reliable MySQL replication is to use the matkit tool, which we've highlighted here. And what that does is performs checksums on the primary database's tables, and then those checksums flow through replication to the slave side, and then you can compare those and sort of verify that your replication is working. So MySQL's replication solution, in short, has a lot of limitations and requires a lot of administration to get it to work. And it can do active-passive clustering, but there are a lot of challenges to that solution. So today, what we're talking about is a similar solution using a low-level technology that's provided at the Linux level, outside of the database's view, that provides you a mirrored file system or a mirrored device upon which you can build your MySQL database. So to MySQL, it's just a single node. MySQL wouldn't know that there's a second node out there. So you can have an active-passive cluster just like you can with MySQL replication. In this case, you're going to have an exact copy of your database because you're actually mirroring physical files. You would see a small performance hit because this is software that's basically a daemon that runs on either node and sends the changes across the network. So, most likely you would see a performance hit. But again, the advantage is that it's synchronous and that you have a clean and exact copy of your database. So, those are some of the big advantages over MySQL's replication solution. So we're going to put this all together today and take you on a step-by-step installation using Sun's VirtualBox technology. Sun's VirtualBox can run on a number of different platforms, so everyone should be able to take advantage of it. It's the installation, the installer itself. I'm not installing the box software because that's pretty trivial. I already have that installed. So what I'm going to do is use that VirtualBox to create a few VMs, and then once I've created those virtual machines, I'll add additional disks onto those, which will support the DRBD. So let's see here. Here's the actual download links. I'm not actually going to download them because I've already installed all this stuff just to illustrate. So let's see here. And CentOS you would get from CentOS.org. CentOS provides Red Hat versions of Red Hat, but with support. So basically, you can install CentOS and get all the same builds that Red Hat has worked on. Okay, so the first thing we're going to do is to take you through step-by-step on creating a virtual machine. And so what I'll do is run through the steps here, and then I'm going to take you back to the GUI and actually perform that. So the first thing you'll do is create a new virtual machine. And then you'll add a 25 meg external disk, a SCSI disk in our case. You'll also want to change the networking interface configuration. The default is outgoing traffic only, but not incoming traffic. But we want to be able to SSH into these machines and allow them to communicate with each other. So setting the networking interface to bridged adapter allows you to do that. Then you'll need to download the CentOS DVD ISO image, which I've already downloaded, and then you'll use the storage tab in your VM configuration assistant to select the ISO image for CentOS. And then finally, you'll start the VM running. Once you start it running, it will boot off of this ISO image. And once it starts booting, it'll run through a standard Linux installation. And it's pretty much straightforward, but again, I'll illustrate that. And then the last piece is to, once that machine, the virtual machine starts up, to edit the etc. host file, which would allow you to have the different IP addresses, so that the two machines can see each other by name as well as IP address. So let me go ahead and start that process. So first thing is to create a new virtual machine. And Sun gives you a wizard to do all this. I'm just going to call our virtual machine test. I'll select Linux, 64-bit Red Hat. I used all defaults for all all of these things. So I wouldn't worry too much about changing settings. The default should work pretty well. This is going to be the root disk partition. So it's the virtual is actually creating virtual disks as well. So that's pretty painless to create a virtual machine. The next thing is we go in and change the network, as I mentioned. Set the network to bridged adapter. Airport, in our case, it's using the airport device in the laptop. So basically all these virtual machines are sharing one networking device. Now we also want to add the external SCSI device. So we go into storage. You can see this is the internal root partition that it created. So add SCSI controller here, and then add a drive to that. It takes the default names here, but we want to create our own. So click New here. And then again, another wizard comes up. And let's call it test data. Test_data. And also we want to make it 25 megs. There you go. So this internal device will come out as dev HDA, and the SCSI one will come out as dev FDA. Those are device files that Linux creates automatically for different buses. Okay. Now the last thing is to specify your ISO image, and that's right here. What's happening is that the you could actually burn a DVD or a CD-ROM drive, actual physical CD, and then have that insert that into your CD-ROM drive and mount it that way. But the VirtualBox software allows you to also mount that ISO directly. So that's what we're doing here. So basically, we've changed the networking configuration slightly. We've mounted the CD. And we've added an external SCSI device, 25 megabyte drive. Okay, so our virtual machine is set up, but again, we haven't installed Linux on it yet, so we've told it where the ISO is, so when we start it, it's going to boot off of that DVD, effectively. So it's trying to boot off of the DVD here. So what's going to happen here is it's going to bring up the Linux installer. Okay. So it should jump right into the installer here. Now, one thing is the VirtualBox takes over your mouse when you click in the window, so you're inside of that window, and you can send clicks as if you're inside the VirtualBox. So all these I use default for all these different settings. Here, when it's asking to partition, this is partitioning and overwriting a virtual disk. So don't worry about erasing data. This is a virtual disk that you created. And then those are the devices that you, and actually, hold on. We don't want to, we're going to use SDA for our own purposes, so we'll leave that out of this process here. Do you want to add partitions? Each 0 is going to use DHCP to find its IP address. And the last step, I didn't install anything special here because we're just using server software would install various other daemons and background processes that we're not going to use. So that's the last step here. So now the installation of Linux has started. As it turns out, this installation actually takes about 30 to 40 minutes. So what we've done is pre-cooked a couple of servers here. So what we're going to pause installation so it doesn't eat up CPU cycles and minimize that. And then we're going to switch over to 2 servers that we've already built. These the names of the servers that I chose are names of penguins. Penguin being the Linux mascot. So these are the root windows. What we're going to do is we're going to jump to a terminal once these machines boot up. So I'm just gonna watch, make sure that everything's booting properly, but it should go pretty smoothly. We're still on the Create Your VMs page on the presentation here. So shouldn't take too long. It takes seconds to boot these machines. If you think that all these virtual machines are running inside of one MacBook Pro, it's pretty amazing. The virtualization technology is very impressive. This is a standard Linux boot process where it starts up various services. And as soon as we reach as soon as we see SSH started, we'll be able to switch to the terminals. So you can see the Ethernet device ETH0 started. And then shortly we should see SSH. Oh, there's SSH. Okay, so let's minimize this Adderley machine, and we'll go ahead and minimize this one as well, and jump over here to the terminal. Okay, and then we'll start another one for African. Okay, so it turns out that I pre-configured DRBD on one of these boxes, Adderley, but not on African. So that will simplify the process. So back to the presentation. I've already installed the Emacs. So basically, there's 2 packages that you need to install for DRBD, and we're going to use the Yum package manager, which makes installing new software very, very simple. So we'll install DRBD and then the kernel module for DRBD. And then we'll configure DRBD as follows. So let's jump over here in Yum, install DRBD. And typically the Yum package manager in the mature versions of Red Hat 5, it's already configured, and it finds mirrors of so it should work out of the box, assuming you have networking up and running. Okay, so it's that simple to install. DRBD, and then kmod-drbd kernel module. And notice that it picks automatically the x86-64 because we're running 64-bit. It automatically knows that. Okay, so while that's running, we'll edit the DRBD file, and this is what the setting is inside that file. Most of these should be pretty obvious. Device is the DRBD virtual device. DevSDA is the SCSI 25 meg SCSI drive that we added to both of these servers. An address is the IP address and the port number. I will make a comment on this that I kind of struggled with this for a couple of days trying to get DRBD to work, and it turns out that the firewall configured by default in Linux is going to block all sort of non-standard ports. So this port wasn't open. And what that meant was that the two servers couldn't see each other and DRBD couldn't talk to each other. So it was failing, but it was failing silently. There were no troubleshooting or debug messages to that effect. So it was pretty difficult to troubleshoot. But once you turn off IP tables, which is Linux's firewall package, once you turn that off, there's no problem. So, for our sandbox, you can just turn it off. Obviously, if you were running in production, you'd want to open this port, configuring your firewall accordingly. So there's two other settings that we didn't talk about. This one, protocol C, and the metadisk. So what do those indicate? So it turns out for most cases, DRBD, you would use C here. And the documentation indicated that was for critical transactional data. The impression that I get is that as you can see from the option A, high latency networks means basically if those two nodes sometimes can't communicate with each other, how resilient do you want DRBD to be out, making sure that those changes made it to the other nodes before allowing a committed change to the disk to be confirmed. So anyway, for our purposes, we're going to use C in most cases. And what does the metadisk indicate? So we specified metadisk internal. Metadisk is where DRBD stores its metadata. This is like header information, sort of administrative information that it needs to store about the cluster and what's happening on it. You can also use an external volume or an external partition. For example, here at devhdi3, if you were to need to swap a hard drive out of your cluster, it's slightly different if you're using metadisk internal or external. But again, for our purposes, metadisk internal works great. So, okay, so back to the drbd.conf. So we've already configured it on Adelie, drbd.conf, and we're going to copy this config over exactly as it is to the other server. Okay, so you can see that we have the exact same file on both sides. Okay, so again, as I mentioned previously, be sure at this stage that you've stopped IP tables. If we had just created virtual machines from scratch, we would have to do fdisk on the fuzzy device, and that's to create a partition because the raw device doesn't have any, it's not partitioned. We've already partitioned them both, but basically you would do fdisk dev sda. You can see there's dev sda1 already created, but you would do a new, add new partition, primary 1, and so on. Like I said, we've already created it, so you can't do that now. So yeah, anyway, you'd have to do admin boxes. The next step would be to do DRBD admin. DRBD admin controls DRBD, and here we're going to create the mirrored device, create-md. And Sean is the name that I gave to this we've defined in the drbd.conf file. So we'll go ahead and do that on boxes. And it's asking these questions because I've done this before, so it's going to overwrite things that I've done before. Okay. The next thing to do is to start up the DRBD daemons on both sides. Now you'll notice that when we start it in one place, it's going to wait and can talk to one. So we start it here and start. And it's sitting there waiting. So we started on the other server. And you'll see they both stop. It looks like they stop, but actually they're backgrounded. So that means they're in communication now, which is good. And if you had your firewall in the way, you would be sitting there forever and wondering what's happening. Okay, the next step is to sync up the data on the two devices. DRBD ADM overwrite data of here primary Sean. This command watch cat proc. I'm going to explain what I'm doing here in just a second. Okay, so you can see that right now it's syncing the two sides. The watch command will continually run the same command, as you can see, every 2 seconds, and it's running cat proc DRBD. Proc is the proc file system in Linux, and it exposes internal memory structures. So DRBD has a file in there, but that it constantly updates with the status information about what's happening in DRBD. What was this overwrite data of peer command? So basically what you're doing is you're running now 2 nodes and saying, use the information I have on this node to overwrite what's on the other one. So if you, theoretically, if you had an RBD and you had valid data, you would make sure to run that command on the node with valid data, because you're gonna overwrite what's on the other node. So so we're almost synced up here. Okay, so now you see that it says up to date, that you want to see. Okay. So now we've synchronized the two dev DRBD0 devices. Now we want to create a file system on top of that. So just as we would create a file system on a SCSI device or an IDE dev HDA device, we create a file system on top of dev DRBD0. Dev DRBD0 is our virtual device, which the DRBD software is exposing to us and is managing for us behind the scenes. So MKFS is make file system ext3 dev DRBD0. So that's pretty quick because it's 25 megs, so it's almost instantaneous. Okay, so now we need to mount the file system. As you can see, it's not mounted yet, so DF tells you what's mounted on your system. Mount dev DRBD0 MNT MySQL. I've already created MySQL. So now you can see that so we have space for the database that we're going to create. Okay. So finally, we get to the step of installing MySQL. Again, using Yum, it's really trivial to install MySQL-server. You don't even have to specify the x86 for MySQL-server. After we've installed the software, we need to change one line in the my.cnf file. And that line specifies where the data dir is. Normally that's in var lib MySQL. In our case, we want to put it on our DRBD device, which is mounted at MNT MySQL. So that's what this indicates here. So again, just to show you, the device is mounted on MySQL. So we edit the, actually we've already edited the my.cnf file. But the only change we made is we changed the data dir to MNT MySQL. So now that we've done that, we can create our starter database. MySQL has a script that does that. MySQL install DB. And you can see that it says OK and OK, which indicates that it had success. So finally, we can start MySQLD by hand here. MySQLD safe. And you can see that it's starting. And we're going to log into the database using the MySQL shell. Use test. There's a test database installed by default. And show tables. There's no tables. So create table Sean Webcast. And I'm just going to create one column. Okay, insert into Sean Webcast. Hello there. Okay. Insert syntax here. Okay, select star Sean Webcast. So we got the data there. Put out. Now we're going to stop the job. That's still running. Okay. Then mount MNT MySQL. Oops. Mount MySQL. Okay, and now we're going to tell the DRBD software that we don't want to be the primary anymore. So DRBD admin secondary Sean tells it to do that. Now we're going to switch over to the other server, and DRBD ADM primary Sean tells DRBD that we want to take control of that DRBD device. Now we can mount it. Mount dev DRBD0 MNT MySQL. Notice that there's a bunch of steps that we only had to do on the one server. That's because these two machines are sharing this DRBD device. So we only have to create a file system once, and we only have to synchronize once. So we've mounted just like we did on the other side, but notice that we're not mounted over here anymore. So we're here. We want to run MySQL, MySQLD _ safe. Connect to the database. Use test. Show tables. Select star from Sean Webcast. Okay, so we're going to insert another statement in here. Insert into Sean Webcast values. DRBD is working. and then start again, and kill the job so that MySQL stops. Unmount again, MySQL, and then DRBD. And then again on the other side, make it primary. And then so we can see that the change propagated properly. I mean, basically, the MySQL instance is only running in one place, so it doesn't even know that that it's running on this DRBD device. For all MySQL, it's running on a single server. So that's basically in essence how DRBD works. Basically, we test switching nodes. So you stop MySQL, you unmount the volume, you use DRBD admin to become the primary controller of the DRBD resource. You mount the device again, you start up MySQL, etc. So that's basically in essence how DRBD works. Now normally in production environment, you would also use this package, I went through the process of installing Heartbeat, and it's pretty in depth and complicated, and there were a lot of hiccups, so that's why I didn't include it as part of the step-by-step install. So I thought I would just kind of go over that high level, how that works. So basically, the main file, there's a couple files here, as you can see, that control the Heartbeat technology. In CD, into etc., HA, and there's a bunch of files. HA resources really is the one that controls everything. As you can see here, you specify the node name, the IP address, the DRBD device, the file system, and MySQL. So basically what the Heartbeat is doing is it's managing that process that we just did manually. So stopping, unmounting the device, stopping MySQL, and then becoming the primary on the other side is basically controlling all the levers to start and stop on either node. But what Heartbeat also does is that it creates a virtual IP address, and this is pretty important because if you're gonna cluster to two servers, you want to be hitting MySQL on the same IP address, no matter what happens, no matter if which node is up or whatever. And so this Heartbeat creates an IP address for which to run MySQL on. So MySQL would respond to all requests from this virtual IP address. And it also performs a Heartbeat function by verifying if a node is up or down, and if one is down, it'll switch over everything automatically. So that's if you were to run this in production, you'd use Heartbeat as well to control everything. So just to summarize all the moving parts here that we've introduced, so DRBD is the main technology, and that gives you the mirrored file system. It's basically software-based SAN. And then MySQL is running on top of that, but again, MySQL doesn't really know much about what's happening underneath. It's just a regular vanilla MySQL instance. And then the Heartbeat technology, which gives you a IP address to run so that all your MySQL servers share a single IP address. And it uses the Linux Virtual Server LVS project to quickly switch IP addresses almost instantaneously. And then it starts and stops services. So that's basically the whole step-by-step installation of MySQL and DRBD together, with all the bells and whistles configured. And basically what the upshot of this is sort of to compare MySQL's replication with this alternate solution that provides high availability for your MySQL. You can do something similar. You can use Heartbeat to control two MySQL servers with active-passive circular replication. But again, as I mentioned previously, the issues with MySQL statement-based replication, in my experience, it still can be problematic. And this solution, you know for sure that both your databases are exactly the same. But DRBD obviously, it requires some additional system administration skills that are beyond the typical DBA, inside the database kind of stuff. And combined with the Heartbeat, you get automatic failover and virtual IP address between folders. So I also included further reading here. A couple books. The Pro MySQL book has been out for a while. It's an A-Press book, and O'Reilly's High Performance MySQL is it's really the newest book. I think it came out, end of 2008, in December 2008. It's really the best book on MySQL right now that I've found. Also, MySQL Performance blog, which I have up here, is very good for internal understanding MySQL and sort of searching on the latest and findings and so on. And then Planet MySQL is also a very good resource for reading up and keeping track of blogs. It's an aggregator of different MySQL-related blogs. So that's it. This is me, Sean Hall. This is how you would reach me and my blog, and I'm also on LinkedIn. So I guess let me switch over
Sean?
to the yes.
Catherine here. We do have a few questions. Do you want to tackle them?
Okay. Great.
Okay,
yeah.
so I'm just going to take them in chronological order, so they may jump around a bit. So the first one is from Brad. He's asking, can you prevent someone from accidentally mounting the file system on the secondary?
It will return an error if you try to mount the file system on the DRBD node that's not in control. So that when you're mounting the MNT MySQL, you're mounting the dev DRBD0 device, which is controlled by DRBD itself, and it will allow one node to be the primary. So it won't allow you. You'll get an error basically when you try to.
Okay. And in a related question from Brad, I think you probably just answered this. He said, does the virtual device on the secondary show up as a read-only device?
I don't think you can. I'm not sure if you can mount it even as read-only. That's a good question. But I know if you try to mount it normally, you'll just get an error. But it may be possible, like you say, it may be possible to mount it. Not sure about that.
All right. And then Joseph is asking, are there any performance decreases caused by using DRBD? Yeah,
I mean, you have software between you. So it's between the file system and the physical hardware device. You have a piece of software running, and it's copying blocks of data across the network. So if you had network latency, that would affect the performance of DRBD, and then the performance of the server itself, because it's using CPU cycles on that box and communicating over the network to send changes. So definitely. Unfortunately, I don't have numbers offhand as to what that impact might be, but it would be a factor of the the CPU and disk speeds of both those machines. And then network latency.
Okay. All right. Good answer. Then Michael is asking, DRBD writes to both drives, but how are reads handled? Can this be used to speed up reads? And if so, can more than 2 machines be used?
Yeah, I mean, it's not the same as, I think what you're referring to is if you have MySQL replication and you have a master and then, say, 2 or 3 or 4 slaves, you can read from all the other slaves. I'm not familiar with if you can mount the additional volumes read only, and I'm not sure if you can offhand. But in the configuration that I outlined, only one of those servers would be running MySQL at any given time, so the other ones aren't mounted at all.
Okay. All right. So Joseph was asking how many servers can you cluster with DRBD, and he said only 2. And then Henry answered him 2 easily, 3 with some additional trickery. So,
yeah, you can do more than 2. And back to the drbd.conf file, only one of them can be the primary, but you can have more than one secondary. And that they would all behave the same way. They would just have to relinquish control before another node tried to become primary. And again, the heartbeat technology can coordinate that activity to make sure that that switch is seamless. But in our example, if you had a third node, you would just relinquish control from the other 2 and then become the primary and then mount the DRBD0 device again.
Okay. All right. And Randall is asking, does DRBD ensure ACID boundary?
Yeah, basically you're completely transparent from the database. So ACID refers to in the database multi-version concurrency control and atomicity. I think it stands for atomicity, concurrency, isolation, and durability. And this is only at a layer below the database, and so there's no conflict between multi-version concurrency control and what's happening below the file system. I mean, basically, when you make a request, so basically MySQL is going to send a request through the file system saying, I want to read something from disk, or I want to write something to disk. Normally, the file system would be talking directly to a hardware device, a physical disk, and so it knows when it's read or completed or write. In this case, it's talking to DRBD, which exposes a virtual device and sends it the same messages. I'm done writing. I'm ready for more information, or I'm done reading. Here's what you asked for. But behind the scenes, DRBD is also doing some other work so that whenever it writes to its own its own volume, it also writes across the network to the mirrored volume, and it receives an acknowledge that write has happened, and that acknowledgement makes its way back to the original DRBD daemon, which then sends the message back to the file system saying I've written. So as far as the file system is concerned, it's the same device, and as far as MySQL is concerned, it says I've written this to disk. So MySQL doesn't know anything about what's happening there.
Okay. All right. So I'm losing context for these questions as they come in, so please forgive me.
No problem.
Someone was asking about LVM, and someone else answered and said, yes, you can use LVM. And then there were some questions about Oracle support for MySQL. I think that was the confusion about your book. Sean is the author of a book called Oracle and Open Source, an O'Reilly book. And then Michael added some further details about the question he asked, and he said, follow-up. I was asking about how DRBD handles reads. It obviously doesn't need to read both drives and could distribute the reads at the hard disk level. So I think you want to comment.
Yeah, I mean, I don't know. I'm going to have to make a guess, an educated guess as to the answer. I mean, when you're communicating with DRBD, you're communicating with your local DRBD daemon, and then it's in turn communicating with the other nodes. If your primary, and in the example that I've illustrated, your MySQL database is running on the primary, you know that what you're, the disk that you're dealing with is the main one, the main copy. So it's going to go directly to the hardware, and it would be slower to go to DRBD daemons. Also, to comment on the previous question about Oracle and open source. Actually, I published that book. Was published, I guess, in 2001, I believe.
Yes.
And
that's right.
Yeah, I mean, I was doing a lot of Oracle and open source integration for many years, and probably for the last 4 or 5 years, I've been focusing mostly on the open source side and MySQL. So yeah, that's the history there.
Okay, so Sam was asking, how about the details around the heartbeat?
Yeah, I mean, unfortunately, I played around with the heartbeat, and it works, but there were a lot of hiccups, and I couldn't get it working smoothly enough to do a demo of it because things wouldn't work consistently, and it wasn't starting fast enough to get it all completed in time for a 40 to 45 minute presentation. But yeah, I mean, it controls all the steps that we executed manually. So it'll unmount the file system. It'll become secondary DRBD. Then it'll initiate the primary on the other side, mount the file system, and then start up MySQL. And the other thing that it will do is it will start up MySQL on a virtual IP address, and that IP address it manages. So by managing that virtual IP address, if it switches nodes, it starts up that IP address on another node, as a IP address on the same Ethernet device. So it manages all that for you transparently.
Okay. And then David was asking, if you have a working system, is it possible to add a second via DRBD?
Yeah, I mean, the back to the command that we typed to say, I think, let me see here. There was a command that we typed to be from the master. Just scrolling up here to find that. MySQL. Here we go. So if you had an already running MySQL, you should be able to copy the contents of your MySQL database. Yeah, it's a good question, actually. You'd probably have to create a fresh DRBD instance and then copy MySQL from its existing partition onto the DRBD mounted volume. So you'd have to shut down the database and copy that over. I think what you're asking is, could it be done while MySQL is up and running? And I think if MySQL is currently sitting on a regular disk, it would have to be copied to the DRBD mounted volume. So.
Okay, we're almost out of time, but I think we have one more question. It's from Sam, and he's asking, how does MySQL handle when it's behind the virtual IP address provided by the heartbeat package?
Not sure what you mean by how does it handle. I mean, in MySQL, when you connect to the server from Apache, or if you connect to the server from the MySQL shell, when you type MySQL, you start up the shell, and it connects by default to localhost and port 3306. But you can also specify --hostname and --port as any hostname or port. And so when you connect to the database through Apache, you would configure inside of Apache how to, the IP address and the port number. And, in the case of Heartbeat, you have one IP address that all of your Apache instances would would connect to. And the heartbeat would automatically manage switching that IP address to different machines. And that would happen transparently. I understand that the Linux Virtual Server project uses ARP, which is like low-level TCP/IP pinging of some kind that notifies the whole network that the IP address is moved to a different server. So it's very fast. It's not like DNS. It's not as slow as DNS. So it's basically instantaneous. So you database like you would any other running on a particular IP address import. So.
Okay, so for clarification, while you were speaking, he wrote, what happens when it's in the middle of an action insert, for example?
Right. What happens is exactly the same thing as if you pull the plug, right? So if you pull the plug and you're doing an insert, if it's a MyISAM table, anything could happen. If it's an InnoDB table, that's an uncommitted transaction. So when the database starts up, it would see all the uncommitted transactions. You know it's going to start up the database fresh, right? It's going to try to mount those all the files that make up InnoDB, the table space that's on it. It's going to see that there's uncommitted transactions, i.e. that you were in the middle of an insert. It's going to roll back that transaction, and then the database will start up. So it automatically will perform crash recovery, which is the same as if you pulled the plug on the server. All right, Catherine? I'm not hearing anyone.
Oh, sorry, user error here. I'm sorry, I was saying I think we're out of time, and I want to thank you for such an excellent, detailed presentation today. Thank you so much. And I want to thank everyone else for joining us today and for sharing your knowledge with everyone else in the chat room. That's always great. So I hope we'll have you back again, Sean.
Yeah, definitely. I'd be glad to. Yeah.
And everyone, I'll send you a link to the recording when it's available. That should just be in a few days. So I'm going to close out the webcast room now.
Okay, thanks so much.